This conference will now be recorded.
Hi everyone, welcome to Isha Training Solutions. We will wait for 2 more minutes for other learners to join and then we'll start our discussion. 2 minutes we'll wait and then we'll start our discussion. Thanks for joining, guys. We'll wait for 2 more minutes. Yeah, so we'll start our discussion. So in our previous session, pretty much we discussed about the course content. What are all the things that we are going to cover like that. Today, we are going to start the actual topic, the day one topic we will start. Introduction to performance engineering, okay, because that clarity is actually important. Okay, we need to get that clarity. What is performance testing and what is performance engineering? Okay, what is performance testing and what is performance engineering? So performance testing, we are going to only test and say, okay, this is what is actually happening. Engineering is nothing but you are going to provide reason, finding solution, fix it, and then check it. So all these are actually engineering part. Okay, testing only will test. Okay, we will test. We'll say I tested this web application and web application is actually performing like this. That's all. Performance testing. But performance engineering is actually little higher than that. You are going to say search transaction is so and so time. In that search transaction, 2 seconds it is actually taking in front end, 3 seconds is actually taking in app server, 2 seconds is actually taking in database server, like that. You are going to provide a detailed information about that problem and also solution. Certain instances you may need to optimize that, resolve it, fine tune it, compress it, minify it, whatever. Performance engineering means you are providing solution for the problem statement. Performance testing means you are only going to say, okay, there is a problem. You are going to only test it and you are going to say that there is a problem. That is where testing and engineering comes into picture. Nowadays, in many top organizations, leading organizations, they are not expecting you to be a performance tester alone. If you are saying I will only do performance testing, they are not expecting that. They are expecting little about that. Okay, you will only say I know performance testing, scripting, execution. No, I don't want that alone. You have to do little more than that. That is the expectation nowadays. That is the expectation. Traditionally, if you go back, people will only do testing, but nowadays it is not the case. You cannot say like I know only performance testing. You have to say I know additional things. I will contribute. I will provide little more detailed insight about the problem statement, be it like APM tool, be it like profiling tool, be it like DB monitoring tool, infrastructure monitoring tool, whatever. I will use all these possible options, and I'm going to provide a detailed information. And in certain cases I have the skill set available, means I will also do fixing. Okay, so it is about whether you have the skill set or you are going to tell somebody to do it. Either way you can do it. Okay, it is not like everybody will do everything. No, you have the understanding to find the problem, and you also have the understanding to fix the problem, means you can do it. Or you have the understanding to find the problem, or you instruct somebody to fix the problem, that is also fine. Okay, that is what the expectation. So now we need to have a understanding between performance testing means what, performance engineering means what. Testing, yes, I'm going to test so and so application, and I'm going to provide the number metric, that's all. But if in the case of performance engineering, I'm not going to stop my journey only with the number. I'm going to go beyond that number. Where is that number? Which layer that number is happening? What I have to do to mitigate or resolve certain problem statement? How am I going to make sure that it is not happening in the future? That's where the engineering concept is actually comes into picture. Okay. And I also wanted to tell this to everybody, like, you are a performance tester for over the period of time. Okay, over the period of time you are the performance tester, and what they will expect from you is that you need to change your skill set from performance testing to performance engineering. And and you cannot simply say I will only do performance testing all years, all months, all days. I will only do performance testing. No, that is not the expectation, guys. Even in my personal life also it happened when I had a one-on-one one-on-one discussion with my manager. He started saying, no, yes, you are doing performance testing, that I understand. But if you are simply doing performance testing, that too you have this many years of experience, and still you are saying I will do only performance testing, means that is not the expectation. You have to do little beyond that. Go upskill, cross skill yourself, and then do or contribute more in the performance engineering side. That is a discussion happen. Maybe in this forum for you guys also this kind of a similar discussion will happen, if you are in the same journey, or if you are in the same zone for longer period of time. Because the expectation is you need to go beyond that. You need to go beyond performance testing level. You should contribute in the performance engineering level also. That is the expectation. Okay, when the experience increases, or when the technology changes, or your customer mindset is actually changes, everywhere performance engineering concept is actually comes into picture. And we have to learn and contribute. We have to learn and contribute. That is what the expectation. Any question, guys, till now? So now we have a clarity. Okay, performance testing means we are going to use the performance testing tool, test it, provide your details. That's all. Okay. Engineering is actually kind of uh, performance tester plus developer kind of activities, because you need to observe, monitor what is actually happening in the application side, where there is a problem, how you are going to contribute to fix the problem. That is what engineering, performance engineering means. You are going to optimize, fine tune, compress, minify, whatever. Okay, so the end goal is you are going to make your application to work in a streamlined way. Your application should work in a streamlined way. That is the expectation. Okay, so a typical example, whatever I mentioned, right? Like you say you are doing a performance testing for so and so application. In that there are business transactions that are there. In that a particular transaction is actually taking 15 seconds. But particular transaction, a search transaction is actually taking 15 seconds. Okay, So maybe I'll ask this question in the forum, guys. Like, you can tell me, search transaction is actually taking 15 seconds. What you will do in this situation? What you will do in this situation? Anybody can answer.
I mean, 15 seconds is more right to for the end user. If any person search for some item, it's like 15 seconds. It's like very long time. So we
Yeah,
need to report that issue, right?
yeah, that is obvious. I mean, how is the answer? So, I mean, question. How you guys are actually doing whenever you are getting a lengthy response time in your performance testing tool level?
Usually, I mean, we will report this to developers or the application team.
Hmm. What you will report? I mean,
I mean,
don't
like,
think like I'm keep on asking question. I'm trying to
okay, okay.
make benefit from your answer. So that is it.
Mm-hmm.
So how in what
Okay.
way we will report that to your development team? Basically, whenever there is a problem, you
Mm.
found that there is a lengthy response time in the performance testing tool level metric, and how you will report it to the stakeholder. Not only for Sindhu. This question is for everybody. If you feel like you can answer, yes, you can also answer. Yeah, Sindhu, you can go ahead.
Uh, Sir, we can check if any query is taking so much time, like SQL
Very good.
query or something.
Very good.
So we can
Ah,
ask the developer to optimize it, to shorten the query. So then after
okay.
shortening it, we can run another test and check if it is again taking the same time.
Hmm. Very good. We need to check the related DB query time, CPU memory utilization at the point. Yeah, correct, Sai Charan. Yeah, wonderful. Any other answers? Any other answers? You can go on mute, Divya. Yeah. So I think yes, you guys tried well. Why I asked this question because in industry right now, what is actually happening? I'll tell you. People are taking the performance testing report, copy, paste, put it in Excel sheet or put it in PPT, and then they are sharing it to the stakeholder. That is what people are doing nowadays. They are not even spending any additional effort. Maybe I mean, Sai Charan has actually tried good answer, Sindhu tried good answer, Divya tried good answer, Shrenika, you also tried good answer. That's the actual step you have to do. But in industry that is not at all happening. I will definitely challenge everybody. People are doing testing, sharing report, that's all. They are not even care about what is actually coming in the performance testing tool level report. That report is actually proper or what, is it actually giving any insight or what? No, nothing. People are only copy pasting and then they're sharing the information to the stakeholder. That is what is actually happening in the real time, okay, in industry. Why I'm saying this, say like if maybe I share this kind of a similar report to my stakeholder saying like search transaction is actually taking 15 seconds. Simply without having any information, without any background level data, if I'm simply sharing this information to my stakeholder saying like search transaction is actually taking 15 seconds means, what reply I will get it from the stakeholder is that, boss, you took 2 to 3 days for requirement gathering, 2 to 3 days for scripting, 1 to 2 days for execution, 1 to 2 days for report preparation, and finally you are saying search transaction is actually taking 15 seconds. Search transaction is actually taking 15 seconds. That I will tell with the stopwatch. Using the stopwatch, I can tell in the day one itself. Day one itself, I can say search transaction is actually taking 15 seconds. But if you are telling after 10 days or after 12 days, you are saying that search transaction is actually taking 15 seconds. Okay, that is not the expectation, right? What the stakeholder is expecting is that, like what Sai Charan mentioned, what Srenika mentioned, what Sindhu mentioned, what Divya mentioned, that kind of a input only they are expecting. Okay, they are expecting you to provide this much of time taken in the front end level, this much of time taken in the app layer, this much of time taken in the EDB. This is what is actually happening in the infra. This is what is actually happening holistically in our application. That is the expectation from the stakeholder. That we need to do it. That you need to provide it to the stakeholder. And in certain organization, as a performance engineer, what they will do, they will allow you to do the fixing as well. And if you are strong in DB queries, or if you are strong in application coding, or if you are strong in UI level coding, no, they will allow you to do the fine tuning as well. Okay, two ways. Either you do it and you ask somebody to do it. Both the way is actually correct only. But what you are contributing is actually matters. Okay, you need to go to the level of problem, root level. You need to go and understand what is actually happening, and you need to provide a detailed explanation for that problem. Don't provide a very blunt, high level, very one liner report to the stakeholder. That is actually definitely will irritate them. That will not provide any outcome. That will not provide any outcome. Okay, so what happened once? I mean, once I've been to Belgium for one of the activity, performance testing and engineering activity. That time, what happened? Actually, the customer itself is actually uh, Belgium customer, right? So they usually strong in French and Dutch. French and Dutch only they are strong. English they'll have a little less exposure. They'll speak, but if you are talking little speed, they will not understand that directly. Okay, so what happened, the performance tester who did the testing, and he shared the report to the stakeholder, I mean to the customer was very unhappy, and he was actually literally blasting the performance tester. He called me and he told what is actually having in this report, what this guy shared to me. I don't understand anything. Because stakeholder is actually kind of, I mean, they are kind of business people, or they don't have sufficient information about performance testing and performance engineering, and you are simply sharing a PPT or Excel to them without having any information in that. How they will understand whether the report is actually good or bad, or the information is actually correct or wrong? No, that is not the way to go, right? So yes, tool is actually giving some information. How I am going to contribute, how I am going to make the tool more meaningful, more meaningful, I need to provide additional information to each of the information that are there in the report. Okay, probably a typical example is how a customer will know what is throughput, how a customer will know what is transaction per second, how a customer will know what is hits per second, how a customer will show request per second. No, right? They will not understand all these information. At least you should type one line in each of the graph. Under the graph you can type one line, what is this graph, whether the graph is actually looking good or looking bad, what you observed in the graph. That observation also you can write it under the graph also, right? But that performance tester did not do that. Because of that, it actually create a bad impression for with the customer. So why I am saying this, performance engineering is nothing but you are making the end user understand what is the problem, and you are making, or you are fixing that problem also. If you, unless and until you have the skill set, you know something about DB, you know something about Java, you should know something about HTML, CSS, JavaScript. Yes, you can contribute in each of the layer, you can fine tune it, you can fix the problem, and you can make your application in a streamlined way. That is what the expectation. But I will say this is not something that is going to happen in a day or two. It is a journey. Okay, right now what you are doing, where you are strong, there you need to contribute, and over the period of time you need to learn certain additional skill, and there also you can contribute. This is a journey, guys. Okay, this is a journey. Over the period you are going to do it. It is not something that today night I will sleep and tomorrow morning I will become performance engineer. No, not like that. There is a starting point in this course journey. We are starting that, and over the period of time you are going to learn certain additional skills, and then you are going to contribute in each of the layer. That is what you are going to do it with respect to performance engineering. Any question, guys, till now? Yeah. So now, introduction to performance engineering. I told you performance engineering is nothing but you are making your application working in a streamlined way by optimizing, minimizing, compressing, whatever the thing that you are implementing it, making your application to work in a smooth way. That is the expectation. That is the expectation when you are doing performance engineering. That can be you can do it across the place. Engineering activity can be done across the place. What you can do, yes, you can contribute in the browser client side level, or you can contribute in the application level, or you can contribute in the database level, or you can contribute in the infrastructure level. Anywhere you can contribute, anywhere you can contribute. Okay, so that is what engineering part we are going to do it. Okay, certain organization they are calling this as performance engineer. Certain organization, even developers they are doing, architects they are doing. Yes, each and every organization maybe they are using different terms and terminology. In certain organization they are doing this DevOps engineering as well. So it's all organization to organization, but end activity is what you are going to contribute and optimize your application performance. You are going to contribute and optimize your application performance. That is the expectation. That is the expectation. Okay, so now whenever we are starting any learning, be it like any development activity, testing activity, performance testing activity, performance engineering activity, anything that we are doing, there is a life cycle associated. Okay, so those who are doing development, they use SDLC, right? Software development life cycle. Okay, those who are doing software testing, I mean manual testing, what they are doing, right? They call it as STLC, right? Software testing life cycle. Software testing life cycle. Those who are doing performance testing, they call that as PTLC, performance testing life cycle. Similarly, here in this course journey, we are going to learn about performance engineering life cycle. Performance engineering life cycle. Okay, because then only we will know what we are going to perform in the performance engineering level. Performance engineering level. Okay, then only you can equip yourself. Then only you can cross skill, upskill yourself to learn certain new concepts and terms and terminologies and everything. Okay, that is what PELC we are going to learn, guys. Okay, so in PELC, okay, I'll explain about probably in line to your development activity. Okay, in line to your development activity, so that you will understand. Okay, performance engineering, what we are basically doing. Okay, what we are basically doing. Say like when in SDLC, okay, software development life cycle. Okay, in SDLC what is actually happening, in comparison to that, in performance engineering what is actually happening, that is what we are going to discuss right now. Okay, so requirement gathering, when developers they are doing requirement gathering. Okay, developers when they are doing requirement gathering, that time performance engineers what they will do in the initial cycle. Performance engineers what they will do, they'll also kind of doing the requirement gathering only. They'll do system sizing information, they'll collect system sizing information, and they'll also think about at what point our performance will be correct. Okay, at what point your system will perform good, like that they will think. And they'll also think about response time related attributes. They'll also think about number of concurrent user that we need to use in our application. They'll also think about business transaction that we are going to handle. They'll also think about growth rate over the period of time. Okay, this year is this much, next year is this much, like that they are going to think about the growth rate also. And then storage requirement. Okay, my application right now with so and so user load, with so and so data, how am I going to use my storage requirement? So that is also they'll think about. So when developers in a normal way they are thinking about requirement gathering, means performance engineers what they will do, they'll think about or they'll collect all these information. What are all the information? System sizing related, okay, capacity or system sizing related information they'll collect it. and response time, concurrent user, business transaction, growth, storage, all these information they'll collect. Okay, during the requirement gathering phase, performance engineers will collect all these information. That is a base. That is a base. On the requirement collection time itself, they wanted to collect all these information because they need to use these information and try to optimize and then make your application to work good. That is the reason they are collecting all these information. Okay, so that first phase, when developers they are doing requirement gathering, means developers, performance engineers, they will do what? All these activities they'll do. All these activities, these information they'll try to collect it. That is what performance engineers they will do. Any question, guys?
I just wanted to know like growth rate and what do you mean by that exactly?
See, growth rate means, say like I'm developing one sample. I'm saying I'm developing one retail based application. Okay, so I'm thinking uh, this year I will get probably 300 to 500 users only. Next year I will get 1000 to 2000 users. That is the data user growth that I'm going to get it. Since because I'm getting 300 to 500 or 1000 user load, I'm going to store so and so data. Retail based application always stores data, right? So I'm going to store certain data this year. Next year, if my user volume or user base is actually increasing, I'm going to store little more data. So that is a growth I'm talking about. Okay, the user
Okay.
growth or data growth, whatever you are taking it. Okay,
Like future,
scalability,
okay,
scalability.
okay.
Yeah. What is included in the system sizing? See, system sizing is nothing but that's what I am going to have so and so user expected in my production. What I am going to invest with respect to my server investment. Okay, 8 GB RAM, 16 GB RAM, 32 GB RAM, 64 GB RAM, or I'm going to 1 TB data, 2 TB data, 10 TB data. So that is what the planning system sizing related information. Okay, so I'm going to think about, okay, the in the early stage, that too this is a brand new application. I may not have a clarity like how many users we are going to get it in the production. In that case, we are going to plan like this. What we are planning, this is what my configuration, this is the machine that I'm going to use it, either Windows machine, Linux machine, or what RAM, what ROM, all those things we are going to decide in the sizing related information. Clear? Yeah. Similarly, okay, next phase, when the requirement gathering phase is actually done, requirement gathering phase is actually done. Next phase is actually architectural review. Okay, developers, after collecting the requirements, developers what they will do, they'll do the architectural review. As a as the developers doing the architectural review, right? Yes, performance engineers can also do the architectural review. Okay, that time only they are thinking about how simple your design and implementation, whether you are choosing a right algorithm and data structure, is there any limitation? Okay, any and every architecture that we are choosing, definitely there will be some limitation, guys. Okay, anything that we are starting, anything that we are doing, there will be some limitation that we need to document it in the early stage itself, that we need to document it. Okay, in the later point of the time, somebody should not come and say that there is a problem in your architecture. You need to show the document to them. Yes, we are already aware of it and we documented it already, so there is no problem. This is a known problem for us. Like that, you need to document the problems in the early stage itself. So whatever the limitations that you feel in your organization, architecture that is actually available, we can document it. So during the architectural review times, you need to think about, is it really simple enough to understand your architecture? Okay, so there should not be complex communication between your entities. That is also going to take unnecessary round trip time and all, right? So entity A and B, if it is actually talking, that should be probably a kind of a easy understanding, or simple designed architecture should be there. Simply designed architecture should be there. There should not be a complex implementation of your architecture. And uh, I mean, for simple activity you don't really require to do complex page navigations and all. You think like this. So I am going to order one computer. I'm going to order one computer. I am going to the landing page of my I'm going to the landing page of my Amazon website. Example I'm saying, okay. I'm going to the landing page of the Amazon website, and I selected the computer. It should provide an option to straight away do the payment. It should provide an option to do the straight away payment. There should not be something like you need to go read the description, read the title, go to the pages, go to the features, go to like that. If you are giving multiple page navigation, and then if you are reaching to the final page, means that is not expected. That is not expected. Okay, so your page implementation also should be very very easy and simple. That is what a performance engineer should do in the review side. Okay, whenever we are reviewing an architecture, first of all we should know, is it actually simple enough to understand it, or it is very complex implementation, or what? It is user friendly, or it is actually complex. For a simple activity, whether you are doing it within the single click or two click, you are achieving the output, or you are doing 5 page navigation, 7 page navigation, like that you are doing it, or what, all the things are actually comes into picture. All the things are actually comes into picture. Okay, so a typical example is, this is your web page, and this is uh, the main content of the page, and there is advertisement 1, advertisement 2, ad 1, ad 2. This is ad 1, this is ad 2, or some ad in the sense like some third party content or something. This is the main content. So this is the page. I'm giving a simple example. This is a page. But what is actually happening when the page loading? This is actually loading first, and this is actually loading second, and this is actually loading third. What you guys are observing here?
Page loading.
Page loading. Okay. What is your expectation?
The
Expected it
main
should
page
load.
load should
The
load
main
first.
content should load.
Yeah, very good. The main content should load first. Why the I mean unwanted cookies or some third party content? Why it has to load first? So I'm telling it from the performance engineering perspective. Performance engineers always should focus on all these aspects, whether loading quickly or what, loading correctly or what, is it a right way to load it or what, architecturally correct or what, implementation is correct or what. That is what you need to think about when you are doing this activity. When you are doing this activity, performance engineering activity. Okay, and they'll also think about the scale up scale out concept also. Scale up scale out concept. When you are talking about architecture, you should also talk about scale up or scale out. Okay, what is that scale up or scale out means? What? Say like I have a machine, I have one server. That server is actually 4 GB RAM. Okay, realistically, none of the machine is actually 4 GB RAM nowadays. I'm just saying for an example. Okay, because nowadays mobile itself is actually more than 4 GB RAM. I'm telling it for the example purpose. One particular machine where 4 GB RAM is there. I mean, uh, people are reporting that there is a problem. Okay, some issue with the application. So what we are doing, we are increasing this configuration from 4 GB to 8 GB, 4 GB to 8 GB. Yes, after doing this we got some improvement in the performance, but still there is some lagging, or there is some issue that is actually happening. So what I'm doing, again I'm trying to increase from 8 GB to 16 GB, 8 GB to 16 GB. Similarly, again I'm increasing from 16 GB to 32 GB. So to a certain extent only you can increase your configuration, right? Because your motherboard, your chipset has to support. Without that support you cannot simply go on increasing and all. To a certain extent only you can increase it. This way of increasing this configuration is actually called as, this way of increasing the things is actually called as scale up. Okay, scale up or vertical scaling. Okay, this is actually scale up or vertical scaling. Vertically you are scaling the machines. Scale up by increasing the configuration in the same machine itself. Within the machine itself, within the machine itself, you are keep on increasing the configuration. That is actually scale up. Okay. So even after the problem is not resolved, means what you can do, you have the option. What you can do, you can create a similar set of configuration, put it under load balancer. You can create a similar set of configuration, put it under load balancer, LB, load balancer. Okay, so this is actually called as what? Scale out or horizontal scaling. Scale out or horizontal scaling. Okay, so nowadays when people are talking about cloud concepts and all, cloud, definitely these things will comes into picture. What is going to come to the picture? Scale up, scale up or scale out, or vertical scaling, or horizontal scaling. I mean, probably many would have heard about horizontal scaling, vertical scaling word only, but scale up, scale out also similar activity only, similar activity only. So the understanding is, where there is a resource level issues, you are going to either do horizontal scaling or vertical scaling to resolve the issue. Nowadays, even in your cloud infrastructure level, if the scaling is actually enabled, where there is a resource utilization problem, it will auto spin the machine, auto scaling. That is actually called as auto scaling. So whether you wanted to do a scaling of what, horizontally or vertically, and I mean, for the temporary purpose it will access the machine. Okay, so that where there is a sudden increase in the CPU or sudden increase in the memory, you can use the scaling concept to resolve the problem. And then over the period of time, if the particular issue resolved, it will again come back to the original state. The scaling it will reverse the scaling. So you will come back to the original configuration itself. So it is all in the recent trends. I mean, when cloud concept is actually comes into picture, people are using this kind of a terms and terminology. So this is also something that you can discuss during your architectural review time itself. Okay, architectural review time itself, you need to think about, okay, scaling. Say, say these things. Why I am telling in the architectural side, because certain times if you are not at all discussing about these things and you are missed to do all these things, later point of time you cannot do any modification in your application. A typical example is, you created one static architecture. Static architecture and after 10 years you wanted to implement any new additional capability into that application, if you are not having the provision in the early stage itself, you cannot implement or you cannot add any new feature into your application. That will become a challenge. Okay, even nowadays people are talking about microservices implementation and all, right? So in that case you should have the provision in the architecture itself. If not, you cannot implement any new changes at all. So that's where I'm saying during the architectural review time itself, developers or performance engineers, what they have to do, they have to think about how simple or easy implementation, what algorithm that we are doing, or is there any known implementation issues that are there in our architecture, or what we have to discuss about the scaling related informations and everything. We are going to discuss during the architectural review time itself. We have to discuss about all these points we have to discuss during the early stage itself. Any question guys till now? Yeah. So next one, when the architectural review is actually done, all things are accepted. Okay, all things are accepted. What they will do, they'll do development. They will do develop. Who will do development? Developers will do development. But what performance engineers will do, they will do code optimization. They'll do code optimization because see, actually, I'll tell you, there are reputed organizations like probably Google or Facebook or whatever. Okay, reputed organizations. What they will do, first of all, they will not write garbage code at all. They will write always a streamlined code only, and certain case, if the junior developer they are writing certain unwanted code also, they will have a practice of doing the code review. Okay, code review. Okay, in reputed organization they are keeping this concept called code review. They'll review the code on a daily code check-in check-out process, right? So that their application will always will be in a streamlined mode. That is what the reputed organization that they are doing. But in certain organizations like CMM level 3 company or CMM level 5 company, what they are doing, they are not actually doing perfect code review and all. Okay, because of that, that will create unnecessary overhead or unnecessary what I would say time you are going to spend, unnecessary time that you are going to spend uh, uh, when you are doing the application usage. So I worked in one of the organization. Okay, I mean in that organization there are 100 developers. There are 100 developers in that organization. Okay, so what happened, as I mentioned, 100 developers. So because of that, some developer will come, some developer will go. Always there will be some new developers. They will come and then they'll go. Kind of a environment, only that environment. So because of that, what will happen? There is no proper documentation also available in that application. So when the new developer, when they are coming to that organization, what happened that time? When the new developer they came to the organization, they did not. Okay, when the new developer they came to the organization, they did not actually have proper documentation, proper KT also happened. No, so what will happen? The junior developer will not have any communication to the senior developer. What is actually available in the application? That application, how it is actually developed? What is the background? Nothing. They don't have any idea about what is actually happened in the applications, right? Because of that, what will happen, the developers they always write certain assumption code only. Assumption code, they'll write it like this: if condition meet, my code will work, else my senior code will work. Kind of very generic high level coding only they usually write. And that too they don't know whether the same code, same logic is actually already available in the application or what. Somebody already written the same logic or what. Those idea also they don't have it, right? Because of that, what happens, there are unnecessary repetitive code was there in that application also. Okay, same functionality written multiple times, same logic they used multiple times, like that. That was the issue in that application. So we went to that application for engineering activity, and when we identified lot of unwanted garbage code was there. I mean, unwanted unused code was there. So once we were able to remove those unwanted unused code, that application started working very quickly. So this is a real time example happened. So why I am telling this, there are situations when the developer they are writing, they will always, developers always think about this code has to work. That is what they will think. They'll not think about other aspects and all. Okay, actually I'm not blaming developers, but I'm telling that is the reality. In reality, what developers they are doing, they are only thinking about functionality should work. I need to deliver this code to the release level activities, so functionality should work. That is what the expectation. Okay, but in the renowned organizations, they are doing extra, I mean, effort to do the code review and other things, so that they are making the application, or they are making the code clean and clear, so that that will work fine. Okay, so that is what I mentioned. When the developers they are thinking about development activity, I mean, functionality should work, but performance engineers they have to think about code optimization part. What are all the things that they can do? Remove redundancy in the code, implement some logic which will reduce the performance overhead, rewrite some portion of code, implement certain optimization technique. This all will help you to optimize your application performance. Okay, some portion of the code also you can rewrite it, because certain times what will happen, if you are having lot of if else condition, if else like that, so all the if else will take additional time only. You need to logically understand whether it is really required to have these many if else condition, or something can be handled through for each, which that kind of a conditional loop also we can use it to reduce your timing, or what round trip time you can reduce it, or what, that also you can think about. That also you can think about. So when the developers they are thinking about development activity, performance engineers they have to think about code optimization part. Code optimization, how to implement it, how to implement, or how to rewrite, how to reduce overhead, how to remove certain redundancy in the code, all those things they can think about. Okay, so these are the things are done by the developers when they are doing this activity. Any question guys still no?
So, so performance tester responsibility to verify the code optimization.
See, right now I mean, as a performance tester you cannot think about that line. Okay, but when you are, I mean, when you are doing all your activity, and I told you right, over the journey you are going to contribute to another layers, means that time you are learning any of your development skill, means that time only you can contribute. Okay, so that's what I wanted to say here. Where you are right now, what you are contributing right now, that is something, and what else you can contribute, what you wanted to upskill cross skill, that is the next layer. So that way you need to think about development activity. Okay, Devanshu, your I mean background sound only is actually heavy. I did not hear your voice, Devanshu. Yeah, heavy background wind, or some sound is actually coming from your end. If you are okay, you can type in your question, I'll answer as well, Devanshu.
I have also typed two questions. Can you please
Oh,
reply
sorry,
that as well?
sorry, two questions. Based on what we will decide the sizing. See, that's what parameters like, what are all the transactions that you are going to use, how many users that you are going to have it, I mean, how many user base that you are going to have it, how many servers that you are going to deploy it, how many region that you are going to deploy it. All those things are actually the parameter to consider, Priyadatta. Okay, you
Okay,
uh,
thank you. And also one more
how
thing.
to collect
You were,
these, sorry.
yeah. So yeah, also like so you told right for requirement gathering that growth rate, capacity, those details like how we can collect like
See, partially it is our experience certain times, and partially we need to do assumptions. Okay, this is what will happen, and probably I'm expecting 300 to 500 user in the initial stage, and this with that volume I'll go with so and so RAM utilization and ROM utilization. Like that, we need to do certain assumptions also. If there is an existing application available with a similar pattern, you can copy the requirements from there, or you can do certain assumptions and then do the implementation. Okay.
okay. Yeah, and also sorry, one more question, please. So, you were telling, right? So, if we capacity increase like from 8 GB to 4 GB to 8 GB, then 6 GB, 16 GB, like that, we can increase, right? If a scalability, if an application needs a scalability. So that can we directly suggest like from 4 GB, can we directly increase it to 8, or is there any criteria based on that we have to
see
increase like because directly we
see
can't increase, right?
yeah, your CPU memory graph or your utilization of your heap graph that are showing a negative trend. Okay, so in that case you are going to consider infrastructurally we are facing issues, and yes, from there only you are going to increase your configurations. Okay.
Okay. Okay. Yeah, yeah. So directly we can't do, right? Based on these things, whatever is
Yeah.
required, we can suggest and based on that. Okay.
Yeah, correct. Sir,
Okay.
do we
Thanks.
need system design knowledge as well for, see, system design in the sense like that is what we are talking about, right? Like how many servers, how many web servers, how many app servers, how many DB servers, which region, what node, all those things are only we are going to discuss in that. Yes, sir, obviously it is actually required, Devanshi. That is actually required when you are thinking about implementation side. Okay. Yeah. So for the learners who joined today for evaluating us, okay, this is Kumar sir number. Okay, this is Kumar sir number 8019952427 is number. Okay, so I'll copy paste this number in the chat 8019952427. This is one number. Another number also I'll give it. Give me a second. So this is also 97015711581. This is also another number. So those who wanted to enroll for this course journey, please reach out to Kumar sir for further information. You wanted to discuss about course timing, course content, fees related, anything that you wanted to discuss, you can discuss with Kumar sir. See, we already started, but there are learners requested us for open it up for evaluation. So for those learners benefit, I'm saying this. Those who wanted to enroll for this course journey, please reach out to Kumar sir for further information. Okay, so this is a weekend session, Monday to Friday holiday, Saturday, Sunday only we are going to have the session, and that too 1.5 hour Saturday and 1.5 hour Sunday, and 7:30 p.m. to 9 p.m. IST. Corresponding timeline is there in the website itself. If you are US student or UK student, you can. If you are a US
Yeah,
student or UK.
actually, I have checked with Kumar sir. Then he have mentioned that in weekend, Saturday and Sunday, we'll be having like 2 hours session each day. So, but you are mentioning that we'll be having only 1.5 hour session. So, I just wanted to know.
No, it's 1.5 hour only. Maybe I'll discuss with Kumar sir and come back on that. Okay.
Okay, okay, because I
Yeah.
have spoken to him yesterday and last week he said that it would be a like 2 hours session. But you can check with him and please confirm it on regarding
Yeah. Yeah.
timings.
Sure. Sure, Sindhu. Yeah.
Oh.
Yeah. Okay. So those who wanted to enroll for this course journey, please reach out to Kumar sir. Tomorrow, yes, we are going to continue the session. Okay, we are going to continue the
Sir,
session.
one last
So
question. What are the tools are you going to teach in this course?
uh, J Profiler, YourKit Java Profiler, J Visual VM, J Console, and Dynatrace, and GT Metrics, Web Page Test, and Lighthouse. Those are the tools. AWR report also,
Sir,
Oracle
actually, I'm
AWR
very
report.
new to this performance testing. So, Jmeter or load runner are you going to teach?
No, Jmeter Load Runner is a testing tool. You can discuss
Okay.
with Kumar sir. He will guide.
Okay. Oh, this
Okay.
is separate course for.
Yeah, yeah,
Okay.
yeah, yeah,
Okay,
yeah.
sir. Thank you. Mm.
Thank you, thank you. So, for the learners who joined today for evaluating, please reach out to Kumar sir for further information. We will continue from tomorrow. Thanks for joining and have a nice day. Bye bye.